therefore a very, very tiny current just from electrochemical cells. So we put two half cells together to create a cell, and that will generate a voltage. If your chemicals are concentrated enough and so on, you can also generate enough current that it can be useful as a cell, like an AA battery, okay, or a car battery where it's a whole lot of lead acid cells in series, one after the other. Electrolysis is the complete opposite. It's where we're actually trying to break apart a chemical using an electric current. So it's the exact opposite. The only thing that stays the same is the rule about anode and cathode. The anode is where oxidation occurs, vowel with vowel. The cathode is where reduction occurs. So that rule stays the same. Everything else changes. Alright, so I'm going to use the colours I've got there because that might make it confusing. Anode starts with a vowel, so does oxidation. Cathode starts with a consonant, and so does reduction. So those go together. That's your thing to remember for the entire topic, whether it's electrolysis or electrochemical cells. This is true regardless. This is important in here because it changes the sign of it. One goes from positive to negative, one goes from being negative to being positive. Alright? In the experiment you're about to do electrolysis to copper chloride. Giving you quite low concentrations because one of the products is going to be chlorine gas, and we don't want much of that in the room. So it's only going to make a small amount. You're only going to leave it turned on for about 20 seconds, okay, until you get that first sense of chlorine smell, and then you'll turn it off. How do we know it's going to be made? Well, first of all, we have to know what's in a copper chloride solution. And we've got our chloride ions from the copper chloride, but we've also got hydroxides. Where have they come from?
Aqueous.
It's an aqueous solution. So there must be hydrogen, or actually hydronium, but let's simplify it. Hydrogen ions and hydroxide ions in there because it's a solution. You can do electrolysis to water. Okay, you can actually electrolyse water, turning it back into its elements. And of course, being a copper chloride solution, it's copper 2+ with this formula. Okay, so we've got those four ions. These ones here are cations, being positively charged, would be attracted to any electrode that was negatively charged. So if I plug it into a power pack, the negative terminal, which is the black one in a power pack, so whichever lead is plugged into the black DC terminal, is going to be our negative electrode. It's where the cations will be attracted. Conversely, the other one must therefore be positively charged, and so when put in the solution, then they'll be attracted to that electrode, the positive one. There's a gap there. At the moment, no current would flow, but why would a current flow as soon as I put it into the solution? Why does that complete the circuit?
Because there's free ions.
Good, there's free ions. Please don't say free electrons in there. There's free ions in there. The flow of those charged particles completes the circuit. Okay, so that's a comment or a phrase you need. Okay, so knowing that these occur, we need to know what the half equations are that are going to be occurring at these. And there's 4 of them. There's 2 for each. Okay, there's 2 main ones, 1 each, but there are 2 other ones for the hydroxide and the hydrogen, which will help explain some of your observations. Okay, by the way, these electrodes in your experiment are going to be made of carbon so that they don't react with the solution. Okay, something that's not going to react. And it creates a nice surface for any deposit of any solid. Okay, it's a very different colour to black. So what we've got here are 4 different starting species. If I look first of all at the negative electrode, because we're trying to decide if it's going to be the anode or the cathode, the negative electrode, let's look at what would happen if copper 2+ is being attracted there. What can copper 2+ be turned into from what we've learnt about so far? There's a lot of possibilities here, by the way. Just copper metal. It could turn into copper 1+ ions. It could turn into copper iodide, but there's no iodine there, so it won't be that. There's a few things it can turn into. Okay. In this case, we use electrolysis to make the pure the element, okay? That's what we're trying to make. So you can be pretty confident that it's going to make copper. I'm hoping your observation will match that, because I'm hoping you know that copper is sort of a pinky browny coloured metal. So if that starts turning pinky brown on the electrode, then you've got it right. This reaction here is going to have the electrons where? On the left or the right? Left. So this half equation is an example of a reduction one. Therefore, is the negative terminal the anode or the cathode? Looking at our rules. Cathode. Now remember that in a cell, the cathode was the positive terminal. So just be aware, this is where it's opposite. It's still where oxidation occurs, but now it's negative. It's the negative terminal.
So once it transfers to like the cathode and it's attracted to the opposite.
Correct. So these are being attracted because this is negatively charged. So out of the solution, the copper and the hydrogen ions are going to go there. Now you might also see bubbles forming. Not many, but you might see some bubbles go, hang on, but the chlorine can't be made there. This is because of the hydrogen. Just be aware, there is a secondary reaction also occurring, not as much as this one I hope, but you have got this reaction occurring as well. So hydrogen gas, there'll be some bubbles possibly of hydrogen gas. I'd expect that. So the one that you want is the pink one, okay? And then the black one is what else happens. At the other electrode, you've got chloride and hydroxide being attracted there because it's positively charged. Again, we're looking at making elements from the copper chloride because that's the thing we're after. So this is why you're not allowed to turn your electrolysis on for too long, because the element that chloride becomes is chlorine. And this is an oxidation reaction. At the same time, you've also got hydroxides being turned into oxygen, by the way. I won't write that one up, but you will see, you could have seen a lot more bubbles there than you'd expect. You've got chlorine and you've got oxygen. Not going to worry about putting that one up though, because it's the same observation, you see bubbles. You won't see its green colour, you're not making enough of it. If you were, we'd have to do it in a fume cupboard. Okay. So what do you need to know about electrolysis? The first thing you need to know about is that it is making pure substances, elements, from a compound. It's doing that by breaking it, lysing it, with an electrical current. You need to remember that no matter what, the anode is where oxidation occurs, cathode is where reduction occurs. So that will allow you to label these two not just as plus and minus, but as anode and cathode. Remembering that this is the opposite to a cell. In a cell, the cathode is positive and the anode is negative. Okay, any questions on that?